So this is from problem set 6.3. It's number 1. We want to rewrite the quadratic function in standard form and get the vertex. So first off, no. Okay. Standard form is when it looks like ax squared plus bx plus c, and it's already in standard form. What it's actually asking for is vertex form, and the only reason I know this is because I looked at the answers in Mobius. And vertex form looks like this, where the vertex is at the point HK. Okay, now there are a couple of ways that we could actually do this. We could use a technique called completing the square, or we could find the vertex and just write the formula in vertex form. But if we do that, then we also have to solve for A. But I will say I think it's, personally, I use completing the square to do this. But I'll kind of run through both of them so you can kind of make up your own mind. I think completing the square is quicker, but maybe it's easier to understand the other way. Okay, so completing the square. Okay, it requires a little bit of a memorization and stuff, but the first thing that you want to do is factor out whatever the coefficient is. So I'm going to factor the coefficient for x squared. I'm going to factor a 5 out of this thing. And this is going to be 5x. Just the coefficient. Don't do a greatest common factor. Okay? Whatever that coefficient is for the x squared, then you always get this number from, well, that constant term divided by whatever you factored out, even if it turns out to be a fraction. Okay? Now, what you want to do is take half of this and square it. Okay. And you're going to add that in the parentheses. Okay. Plus, I'm going to take half of it and square it. Now, you can't just randomly add numbers, right? What you have to do is the only number that you can add is 0. And I've just added something else. Okay? But you have to be really careful, because since I put it inside parentheses, what I really have here is 5 times the 5/2 squared, which is 125 over 4. Okay? So since I added 125 over 4, I have to turn around and subtract that as well. Now, the reason for doing this is that it will factor, because we just made a perfect square trinomial, and it's going to be x minus whatever number you put in the little parentheses there. So in this case, it's 5/2 squared minus 125 over 4. Now, because now I have it written in vertex form, okay, I know the vertex is at 5/2 and 125 over 4. I think that's the easy way to do it, because you only have to make, this one little computations to stick the numbers in there. Now, your other option is just to find the vertex and pretend you're almost starting from scratch. Okay? So if I do that, then my function was 5x squared, minus 25x. My vertex formula says x is at negative b over 2a. So in this case, that's a negative 25 over 10. And if you reduce that, you get that was a negative 25. So that's negative. You get 5/2. Because you get a positive 25 over 10, you reduce that fraction. Then you go back and evaluate your function at that point. Okay, so if x equals 5/2, and you substitute that back in You get 5 times 5 halves squared minus 25 times 5 halves. And let's see. Oh, I messed up a sign too, by the way. Negative 125 over 4. That was a negative over here, and I did not write that down here. Okay. So then, since I have that, I know that f of x is something times x squared minus 5 halves minus 125 over 4, and then I have to figure out what a is going to be. Okay. Now, because I know I'm going to wind up distributing, okay, that when I multiply that through, I better get 5x squared. So that makes it kind of pretty obvious that a is supposed to be 5. Wow, I don't know what I'm writing there. 12 over 5, where'd that come from? So there's another way to do it if you just want to use the vertex formula. I kind of like the completing the square. I think it's just a touch quicker. But either method's going to work, so go for it.